Okay, in this video we will discuss on non-inverting amplifier. A non-inverting amplifier is a type of operational amplifier circuit that produces an output signal in phase with its input signal. This configuration provides high input impedance and stable operations. Last video we discussed on inverting amplifier, where we have the input signal is inverted by 180 degree so that it will produce out of phase with the input signal. Here we discuss on non-inverting amplifier, which will produce the same phase in the output. Okay, so this is the circuit for that one. We provide the input signal to here. This is a positive terminal, and which is non-inverting terminal, which is minus is inverting terminal. Okay, so the output is fed back to the input by a feedback resistor RF. Then we have one more resistor R2 should be connected to the earth or ground. Okay, that's why we have a potential divider arrangement here. From the output there are RF and R2 will be fed back to here. So if we measure the voltage V1, it should be equal to the potential divider arrangement, that is V output R2 divided by R2 plus RF. Okay, this is the voltage here. So if you do the analysis, we have find V1 is equal to V output R2 divided by R2 plus RF. Okay, this is the voltage here. Because of the high resistance, high input impedance of this op-amp circuit, we have the same voltage will be provided to here. So V1 should be equal to V input. Okay, V1 should be equal to the V input. Then we can find the gain. Okay, the gain AV is equal to V output divided by V input. So V output divided by V input, but we know what V input is V output R2 divided by R2 plus R. Okay. We can make the substitutions here. V output divided by V input. We can cancel out the V output. Therefore, you get R2 plus RF divided by R2. Then you get to the transpose to give AV is equal to 1 plus RF divided by R2. 1 plus RF divided by R2. Therefore, you get this is the your amplification factor. Because if you decide RF by R2, we can actually design your required amplifications for this circuit. Okay, so the another modification to the circuit is to change to voltage follower. Voltage follower means you get the same output as input. Okay, so what you do is you can just remove this one of this RF feedback resistor and set your R input relative to infinity. Therefore, your equation become V output is equal to 1 plus RF is 0. Then by infinity, you get this term will cancel. Therefore, you get V output divided by V input. At certain stages, you need a buffer amplifier where you need a high input impedance and a low output impedance. You can actually use the voltage follower for the buffer amplifier. Okay, let's implement your non-inverting amplifier in LTspice. So this is a circuit we are using for non-inverting amplifier. We have an op-amp OP07. Then we should connect this positive and negative power supply with the minus 12 and plus 12. Then we have to connect the resistors R1 and R2. This is a feedback resistance. I just put 2. Therefore, you are 1 plus RF by R2. There will be 1 plus 2 by 1. That is 1 plus 2 is equal to 3. So you should amplify your signal by 3 times. Okay, then we have this signal. The signal is provided here. So this is a parameter. So we have the sine wave of DC offset 0, amplitude 1, and the frequency is 30. Okay, that's a signal we are giving. Then we should amplify the signal and we will measure the voltage across this. Okay, just run the simulation. This is simulations. We have given transient simulations of stop time 0.2. and times to start that at 0 and maximum time step is equal to 0.0. Okay, then we can close it and just run this one. Okay, if you run this program, so this is input we are giving. So just measure the input here. Okay, so we get a signal. Okay, sine wave of 1 volt. Then we should measure your output from here. Okay, just to measure the output from here. Okay, so this is output now. So this is showing a 3 voltage amplifications. Okay, 3 volt amplifier. Actually, it's amplified. Okay, let's try a different feedback voltage feedback resistor and see what is the changes happening there. So let's say 10k is applied here. Okay, then the amplification is 10 times. So if you run this one, so it's amplified to about 10 volt. So that's why we can actually choose any suitable combinations to get the suitable voltage for this one. Okay, then we will actually check this voltage field follower also. Okay, it's a buffer amplifier. So this is the buffer amplifier circuit. So actually what I do is I just remove this resistor in the feedback. R2 is removed. Rest of all these circuits are same. Okay, if I run this program, you can see the input is again 1 volt, and if you measure the 1 volt, this is also same. That's why same. They is showing the same 1 volt, which means that it's actually a buffer amplifier.